Electricity has fundamentally reshaped our world, driving unprecedented advancements across industries and daily life. Throughout history, electricity has evolved from a scientific curiosity to a fundamental technology. This timeline shows how developments in wireless communication built upon electrical discoveries. Visionaries like Nikola Tesla revolutionized our understanding of electricity. Tesla's innovations, including the Tesla coil shown here, laid the groundwork for modern electrical systems and wireless energy transmission. Today, electricity is the invisible force behind almost every aspect of modern life. From simple household devices to complex digital systems, our world runs on electric power. The landscape of electricity generation continues to evolve. This chart shows the changing mix of energy sources over time, with renewable sources increasingly contributing to global electricity production. Electricity has transformed virtually every sector of society. From healthcare and transportation to communication and manufacturing, electric power has enabled incredible advancements that shape our daily lives. Looking ahead, electricity will continue to evolve. Key trends include greater integration of renewable sources, smarter grid systems, widespread electrification of transportation, and ongoing efforts to decarbonize power systems worldwide. From a scientific curiosity to an essential global resource, electricity continues to power innovation and reshape our world in profound ways. Its transformative impact spans all aspects of society and will remain central to humanity's future. The fundamentals, understanding electricity. At its core, electricity involves the movement of electric charge. Electric charges create electric fields, and their motion constitutes electric current. Electric fields are intrinsically linked to magnetic fields. Electricity and magnetism are fundamentally linked. Together, they form electromagnetism, one of the four fundamental forces of nature. This visualization shows how electric and magnetic fields distribute around a dipole antenna. When electrons move through a circuit, they create a flow of electricity. This animation shows how electrons flow from a battery through a circuit to light a lamp. Electricity comes in two main forms, alternating current and direct current. Direct current, or DC, flows consistently in one direction. Alternating current, or AC, periodically changes direction, creating a wave pattern. In practical applications, alternating current is used for power transmission over long distances. Power plants generate electricity that's transmitted through power lines to homes and businesses. This system of transformers and transmission lines forms our electrical grid. Direct current, on the other hand, powers our electronic devices, batteries, and solar panels. Understanding these fundamental concepts is crucial to appreciating electricity's vast applications in our modern world. Electrification across sectors is rapidly transforming our world. The increasing electrification of key sectors is driving global electricity demand while reducing reliance on fossil fuels. In transportation, electric vehicles are rapidly replacing combustion engines, reducing our dependence on fossil fuels. EV charging infrastructure is expanding globally, while advances in battery technology continue to improve vehicle range and efficiency. In buildings, electric heat pumps are revolutionizing heating and cooling systems. These devices can be up to 4 times more efficient than traditional fossil fuel heating. Industries are increasingly electrifying their processes. Electric motors and automated systems are replacing manual and fossil-powered machinery. This widespread electrification is crucial for achieving our net zero carbon emissions goals by 2050. As we can see in this projection, emissions across all sectors must decline dramatically. To support this transition, we must rapidly expand our clean electricity generation and transmission capacity. This infographic shows the current U.S. electricity mix, which will need to shift toward more renewable sources. Electrification offers numerous benefits, including improved energy efficiency, reduced carbon emissions, decreased air pollution, better integration with renewable energy, and enhanced control and automation capabilities. As we continue to electrify all sectors of our economy, we move closer to a more efficient, sustainable, and cleaner energy future. The energy sector is currently undergoing a profound transformation driven by three key trends. These trends are known as the three Ds: decarbonization, decentralization, and digitization. These three trends are reshaping how electricity is generated, distributed, and consumed, leading to a more sustainable and resilient energy future. Decarbonization refers to reducing carbon emissions in electricity generation, primarily by transitioning from fossil fuels to renewable energy sources. Achieving net zero carbon emissions by 2050 requires several critical actions, including increasing solar and wind capacity, eliminating coal power generation, and electrifying transportation and buildings. Decarbonization strategies include the expansion of renewable energy sources, phasing out fossil fuel power plants, and developing carbon capture and storage technologies. Decentralization involves moving away from traditional centralized power systems towards distributed energy resources. This image contrasts yesterday's centralized power system with tomorrow's clean decentralized power network. The shift represents a fundamental change in how electricity is generated and distributed. Decentralization enables consumer power generation through technologies like rooftop solar, supports microgrids and community energy systems, and creates greater grid resilience and flexibility. Digitization involves using advanced technologies like artificial intelligence, predictive analytics, and the Internet of Things to optimize energy systems. Modern energy infrastructure, like this solar thermal power plant, increasingly relies on digital systems to optimize operations, from the heliostats collecting sunlight to the final distribution of electricity. Digitization enables smart meters and advanced grid management, predictive maintenance of infrastructure, and automated demand response systems that balance supply and demand. These three trends don't exist in isolation. They work together to create a more sustainable, efficient, and resilient energy system. Decarbonization enables a shift to clean, distributed resources. Digitization optimizes renewable integration and manages decentralized systems. Together, they create a sustainable energy ecosystem. Beyond environmental benefits, the energy transformation driven by the three Ds also has significant economic impacts. As we transition to cleaner energy, employment patterns will shift. This graph shows how jobs are projected to move from fossil fuels toward renewables, energy efficiency, and grid enhancement. The transformation creates jobs in renewable energy and grid modernization, enables new business models and market opportunities, and reduces health and environmental costs associated with fossil fuels. The three Ds are creating a pathway toward a more sustainable energy future. Together, decarbonization, decentralization, and digitization are reshaping our energy systems to be cleaner, more flexible, and more efficient. These transformative trends are accelerating renewable energy adoption, empowering consumers and communities, and creating a more resilient energy infrastructure for future generations. Several countries and regions around the world are implementing innovative approaches to renewable energy integration. Denmark has established itself as a world leader in wind power integration. Around 50% of Denmark's electricity now comes from wind power. They pioneered offshore wind technology and can export excess renewable energy to neighboring countries. Hawaii has set an ambitious goal to become the first state in the U.S. to run entirely on renewable energy. Hawaii aims to generate 100% of its electricity from renewable sources by 2045. The state has already reached 30% renewable generation, driven by solar and wind. Its geographic isolation makes energy independence particularly important. Indonesia's Sidrap wind farm showcases successful public-private partnership in renewable energy development. The Sidrap project is Indonesia's first utility-scale wind farm with 75 megawatts of capacity from 30 turbines. This successful public-private partnership now powers more than 70,000 homes in South Sulawesi. Let's look at the global progress in renewable energy. In 2023, renewables accounted for 30% of global electricity production, This included hydro, wind, solar, and other sources, showing significant progress in the energy transition. A key factor in these success stories is effective grid integration across different scales. Renewable energy sources can be integrated at residential, community, and utility scales. Each scale contributes to the overall renewable energy mix and helps create a more resilient power system. These case studies demonstrate several key factors for renewable energy success. Policy support is critical for renewable adoption. Public-private partnerships accelerate development. Geographic factors influence renewable strategy, and integration at multiple scales enhances grid resilience. The future of electricity is rapidly evolving toward a world powered by clean energy. The world is likely entering a new era of falling power sector emissions. This decline is primarily driven by the rapid expansion of solar energy, a rebound in hydropower generation, and increased energy efficiency. Solar farms are leading this transformation, becoming increasingly common across the globe. Meanwhile, hydropower continues to be a reliable source of renewable energy, with ongoing improvements in efficiency and capacity. Achieving net zero carbon emissions by 2050 is a global ambition that will require significant changes across all sectors. This transition requires a significant increase in electricity use, supplied by cleaner energy sources, and widespread electrification of transport and industry. The future home will be a hub of clean energy technology, with solar panels, energy storage, and smart systems working together. These homes will feature solar energy generation, battery storage, electric vehicle charging, and smart energy management systems. The future of electricity is one where clean, reliable, and affordable power drives sustainable development for all. This vision brings multiple benefits: reduced climate impact, increased energy independence, new economic opportunities, and improved quality of life for communities worldwide. As we look ahead, it's clear that the future is electric and increasingly powered by clean energy.